So we're taking this last impulse then to you, Bruno. You see that on an automotive company, probably you have worked also in that field. Is there anything construction can learn, or are they more learning from us and optimizing it or perfectionizing it?
Yeah, what construction can, like I was involved in the Toyota Olympic car that had a lot of 3D printed parts built inside, and it took, I think, 2 years just to get the certification to put it on the streets. So this is one part, and it took, I think, 2.5 years just to develop these parts by design with all of the testings. So additive manufacturing comes with a load of complexities that we are not yet able to handle in construction, because not even, or the automobile industry is also not ready to handle it. So I'm not sure if we need better solutions, better tools to actually be able to handle the possibilities that we are now able to fabricate. So it's kind of the other way around. Like in reality, it's very complex, and we lack the means of simulating, of assessing these parts.
Anything to add on that, Max? Or on the collaboration part or improving part? If you're not there, maybe we need to change also the method of working together.
That's for sure. I mean, there's so much happening and so much energy that companies like BMW can invest in their research. So finding ways of translating this to like the more basic needs of our industry, for example, that certainly be interesting. But there's one thing that strikes my mind when I see the presentation of her, and also saw some pictures from Harald in the morning, like these blob buildings in the early 2000s, where everyone was like super happy about like we can do fancy forms, and it will also like just change the world which we live in, and then again seeing what we talk about in circular industry and everything, which is not related to these complex forms, where we need complex technology to create complex forms. So I'm just wondering a bit more of like how can we kind of regulate this energy into the direction of what we need.
Yeah, like, we had this with Harald this morning with the new logic of form, that you use that to only print or produce what you really need, and not just for the sake of beauty or for the sake of blob.
I mean, I think that one of the lessons that came from parametricism, so what parametricism let us do is create digital complexity in the material world. And I think what we see with the new generation of robotics, the new generation of technology, is that we use these tools to perceive and understand and build with the complexity that exists in the real world. So when you look at recycling materials, reusing things, reusing car parts, all of this is using that same understanding of we have 1,000 variations, but you're not artificially generating these variations. You're looking at the variations in the world, and you're pulling them into your model and letting yourself build with those.
No?
There's also one thing, you mentioned that BMW has the resources to put in research. You started the impulse with open source because you can't have the resources to develop something, or innovation cycles get faster and faster, and you can't catch up with that. So I think all of you somehow were supported or had an environment to evolve, or maybe you can refer to that a bit, Bruno. In your environment, you mentioned you survived, yeah, and you had a company, Orion. Maybe you can put a take on that, your environment to involve.
Yeah, so what's really important is the research environment, to have a group of people that you can ask, that you have also on quick dial if there are big problems. Like, and these environments happen at universities, happen in research. But the added complexity of generating value out of this is really a tough one. So I think, for example, an environment where you could do experimental building, I think we all would like to try out these things in reality and see how our things perform. This is, for example, lacking. Like, there are multiple things.
Yeah, I mean, in our case, we also, I think, we're a startup. We're also a spin-off. We spin out of the Robotic Systems Lab from the ETH. You'll actually see Marco's lecture, I think, coming up next. And there, I think what's important is that you have time to take risks in university. You know, we have something like 50 man-years of research that have gone into this very young company. If you look at the Silicon Valley model of startups, it's, come up with an idea, raise a bunch of money, and then try to build on that idea. And I think when you come from the academic side, you have this weight of intellectual understanding, but at the same time, you don't have that starting seed of how do we apply this? How do we bring this to bring value into the industry? Because what you're thinking about is the hard problems, not necessarily the problems that you have to solve, that the world needs you to solve.
I just one point to that. Exactly true. Like when we started, we knew how to 3D print, but we had no idea of construction because you don't have the time to do all of it. Like what they say, like you're only an architect when you're 50. Like how are you supposed to do a construction startup when you don't know how to, when you only are good with the detail? So you need an environment to be able to do that.
May I add, I mean, you do a construction startup when you don't come from that industry. So it's easier than probably to come from another discipline to do a construction startup and then integrate architects and engineers on that. But getting back to the safe environment or to something you put research in, you experiment, Romana, the open source, and then Max the second. No. Also the open source, the research you have done. So this is something which has also a responsibility to society. So it's really, I imagine it's really difficult to convince people or make people get into that.
Yeah, I guess, I mean, the problem of getting people to use open source is both, on a cultural level, but then also on an operational level. So it's very hard. I mean, for example, architects, right? They are driven by competition. So if you get to develop a tool that advances you from others, you would not necessarily want to share these. And then also, like, probably there is not enough resources, right, to even in their own architecture companies to consolidate what they have developed in order to reuse it for the next, right? So I think we need both to push for different culture. Is it what you meant?
Yeah. I would also dig a bit deeper on that. What would, from your personal opinion, are the biggest hurdles or pushing that what you're doing at Vision, or you both the question? So how you continue or imagine Vision to be in 5 or 10 years when things are developing in parallel or advancing in parallel?
Yeah, I mean, I think since I stem from academia, right, I didn't think about, right, doing open source because I already did open source during my academics. So I think it's some sort of, I need to do it because it just makes sense to not reinvent the wheel over and over. And I think with that state of mind, right, I also entered Vision because this is, and I think companies are changing. So as Max mentioned, there's a lot of big players that are open sourcing because simply they see this value, not in terms of societal relevance, but then also, they would not be able to survive. And I think it's the same for Vision.
Survival is a good point, and I'm actually quite critical about these safe environments. Because I think they kind of, like, if you stay away too far from reality, you will never get back to reality. So a bit like, I'm provocative right now in the industry panel, but I mean, of many of the presentations that I see, it's like I have a solution and now I'm seeking the problem. And that's not how you kind of come up with a value proposition that someone on the market picks up quickly. So if you have too much time, and that's what I also learned from working 4 years at a construction company after founding a startup and going through all of this, I mean, the ambitions are just way too high to make a profitable case out of things. Like many want to solve a problem that's impossible to solve with the resources you have at hand. That's why I'm calling also for open ecosystems. We as like small startups with like bright minds but almost no money, we need to be able to dig deep on one point and really be the best in that one. We can't solve all the relevant aspects that are related to all the ideas that we have. Like, no one is building a CMS, a content management system, from scratch anymore. But you can just take what's there and add something on top and make a business out of this. And I think that's something that we really need to discuss much more, like how can we work on small things and be the best on them, and then others can pick up on them. Like that's with Autodesk Revit. Like you can make a Revit plugin, but then you're limited to just a certain amount of people, and only the people that live in that silo. And I think there's huge potential. And like after working 4 years at Implenia at the construction company, like just referring to what problems they have on site, and what we talk about like generative AI and stuff is just like two different worlds. It's two different bubbles. And still, they have quite interesting problems to solve.
And how did you come with vision? If it's you had probably many ideas before, what makes you then to say, okay, that's the needle, that's the point I'm addressing because I spotted.
It's way too big. We will not solve all the problems that we tackle with it. It's a learning from it, and I think that's also interesting about the open movement, which is not only related to code or to data. It's really open knowledge. It's also sharing of what's not working out. And one big issue that we have with vision is that we can't replace existing processes from A to C. Like we can offer a piece of it, but then people still have to use their old tools, which will make it very unlikely they will jump on our tool and work a little bit with it and then jump back in the old world. So we have just more ways to plug in modular stuff and make it work.
And I am then provocative, you making a software or an application.
Yeah.
In your case, that's you getting to the ground. So how are you making construction companies then to actually use? So a test run is quite a different thing than to having maybe in parallel to a competition run your software and testing that. Have you already a key lead user?
Yes, so we have a few good pilot contracts, and right now we split ourselves between the kind of excavator manufacturers and the construction companies. I think there, the most important thing, and this is something we're still figuring out, is like, you have to add value. In construction, I think, how many people know this, is the margins are one of the lowest of any industry. You have 2.8% profit margins. So any decision that gets made is always about that dollar saved, and it's about how many millimeters of imported gravel do I not need if I use this solution. And so I think for us, it's a lot about really talking to customers and understanding those things that, it's not, the value saved is not about the taking a driver out of a machine. I think it's the first thing you think. It's about the scheduling, being able to say, I'm going to be done at this time, so the concrete truck doesn't slow down. Being able to say, you're going to have this much material savings, you don't have to bring in these extra 3 trucks. All of those things, not idling trucks while you're waiting for things. It's good for the environment if it saves construction companies money. So we kind of start from the money side, and we hope we do good the other way.
One question to add, because the startup bubble always likes to pivot or to change something. If you take rule number 8, don't dig. What are you doing if digging is forbidden for the future of construction?
I think we would have a very hard time in the world if digging is forbidden. And it's not impossible. Of course, we build. I think we've shown as I showed, the largest case of actually using these machines to build things above the ground, using things that were extracted in a kind of very low carbon way from demolished buildings. I think there you have to remember that it's still not zero. You have to truck things. You have the work of removing things. You have the life cycle cost of exposed rebar and failure of these modules. I think, we come up with many solutions. They all have downsides. I think the important thing is that we keep trying, that we don't give up, and I think we have to keep building, but we try responsibly.
That's great. Maybe also to the audience, if someone wants to raise a question or has something to the panelists, please feel free to enter the discussion here. Harald. The microphone is coming.
Yeah, thank you very much for these nice industry insights. And I have a question to Franziska, who is already not sitting here. So, I don't know where she's.
I'm taking the ones we only intended to make.
She mentioned that
impulse.
in car design, in car industry, the design is getting more complex in the interior and also in the outer surface. And I'm asking, why? So what is the meaning of this getting more complex, of this more complexity, more material mix, more complex surface structures? And the second question about when I reflect Corentin's presentation in the morning to the effort on how to reuse parts of the building. So is there any idea of the car industry to what we do with all the existing cars? So can we reuse part from existing cars? So is there also a kind of synergy in the discussion?
So may allow to take that into that panel if we, as we said, we keep the car automotive only as an impulse from another industry and stick to the building of the demolition, if that is fine for you. That I mean, the complexity in design is the same for architects. Bruno mentioned it. An architectural company approached you to make a facade. So I could also be provocative and say, what's the reason for that facade? Whoever needs that. And you also make then in architecture things up and complicated. And then, but the parallel is quite interesting. What happens to the old cars? What happens to the old buildings? I mean, Stephen Brand made in the 90s How Buildings Learn, and no one, he was not even an architect. So we have still a problem with our unused buildings. Same thing with fashion. So why do we need to be dressed in different things each year? So I would rather go back to construction than Harald, if that is fine for you, and keep it on that round. Katrin, you want to add something?
Yeah, actually, I can quickly maybe follow up on this. What is really interesting on this open data movement, is accessibility. So I think what you showed very nicely, Ryan, is basically working in a context. You have this machinery that is now capable to work with a complex environment. And we had this discussion actually yesterday with Charlotte. When you open up a CAD file, it's empty. So this still comes from a sort of very modernist approach of that you do something on the blank page. And I think it's a very nice observation. So that when we open up the CAD model, the CAD file, usually the first thing that architects do is try to get the context from somewhere. It's almost impossible if you don't have your secret channels, to get really good data from a certain context. And then it's just the geometric data, but there's so much other information that you need in order to do an informed design process. So I would really like to hear your sort of take or sort of future vision. And then also having the technology available to then deal with this data. How do you see where this goes to, and how can this basically inform our new software that we should use instead of this blank white page when we open up?
Yeah.
You start.
Okay. No, I think, you're right. I think everybody that studied architecture knows that you spend a lot of time in converting from one file to another file. You have a software where you cannot use that, etc. So it's very much, what we need is simply better interfaces, right? Data is at different kind of locations, and it must be more open, or there must be some agreement on these interfaces, on the data, what it needs to be looked like, rather than, on the file itself.
But that's why one of the reasons why I started Open Source Construction, to give different players a platform to come together and formulate their needs. Like one project, for example, is that if you detail a component in one software, you can't just hand it over to another software that calculates the LCA, or you can't hand it over to Energy Plus to run simulations. In every software, you have to reset it up again because there's no interface to set it up. And so we just bring together like software suppliers and say, okay, how do we define a multi-layer component to have it interchangeable? And it's doable. We just need to do it. And we also need to ask for data, because there's so much data out there, but everyone says we need it, but there's no consolidated demand. And
I think that to that software side, I think one of the places where we really have to push is that malleability onto the construction site. So we always get to design, even if you're designing with reclaimed materials, where you come up with some design, and now you say, we're going to build this, we're going to take this building apart, we take these beams, we put them back together. As someone who's worked with a lot of reclaimed buildings, you find one's filled with termite holes, one is rusted and broken, and you've got 90% of this thing that you started building. What do you do in that moment? You, of course, order a new thing from some factory somewhere else. You can't use 100% of that reclaimed material and not have malleability. So I think what's very important is that we come up with design tools that let us do what construction workers do all the time, which is an architect gives them a drawing, and they realize, hey, that pipe doesn't actually fit through the wall here. I'm going to drill a hole. And I think we need the tools that we build to be able to adapt on the fly and understand really the high-level performance goals. This water has to go somewhere. This roof has to cover someone. And that's a very hard thing for an architect to get behind. It's like, you're not designing anymore the shape of the corner, the detail, you're designing the performance requirements. I think it requires a lot of change.
So may I take it once back to Bruno, because you're getting then away from the worker to the interior design, you narrowed it down because construction is so difficult. Where do you see the improvements in interior design if you integrate also sustainability and not to make fancy just for the beauty sake stuff, but to...
I think the main problems that we will also discuss now in software is that you kind of have to define a process. And for our case, what we figured out is that there is no process yet for additive manufacturing in construction, and you need to have a community to establish this process altogether. Until then, we will, of course, we're still working on doing the load-bearing parts, not just interior, but until then, we focus on making our own internal processes, which are basically products. So we are focusing on products that have the whole pipeline in there, that are made for additive manufacturing, that are where we can create a value, where we know exactly what will come out and what the inputs are that we need, so that it's not just this tool that you play around with, that it can solve theoretically a lot of stuff, but then not really. So we want to be responsible about the process chain, about the materials that we use, and create these products.
Are workers part of this community for additive manufacturing? I mean, the carpenter, the one who is on site?
Yeah, so we just scaled up. So we are now 16 people. We have, it's almost 50-50 of people that sit in the office and workers, even though we do prefabrication. From our case, it's like, okay, we do prefabricated elements and then we deliver them on site, and then mostly it's another person's problem. But I think the tasks are still way too complex to have it completely automated. But I don't really have an answer for that.
Max?
I've just been talking to one of the largest demolition companies in Switzerland last week by accident, and what I learned, and we also discussed the different stages of like how can we reuse materials. Like reuse is the top level that everyone wants to go to. It's the least effort of doing stuff, but all the way down to recycling, there are certain steps in between. And what they're pushing forward is to find collaborators to kind of create new materials that don't have primary demolished materials, like, but secondary Primärrohstoff, Sekundärrohstoff. I don't know the English terms for it. But I mean, that's also why it's interesting about the way you use materials. I mean, there's a huge space for like just coming up with new compositions and creating new materials that we can then, or like products that we can use to build buildings, apart from just taking an element and putting it again in the new one. And also like raising awareness of this and spreading the information, making this information available in the planning tools that we use to evaluate it and understand the impacts of it. It's also something that we need to kind of just make more easier to understand to also decision makers.
Thank you very much. So we have one last question from the audience. Who wants to take it before we close the panel? Please.
Yeah, thank you. I'm having a question regarding the file types, or generally the open source mind of the unifying everything digitally. Is there a working group or something, or is it such a new field of engineering that there isn't any direction and you have the opportunity to lead us somewhere? I
mean, there's tons of open source projects that are relevant for the industry already there, and that's one part of what we do. We compile it together with OSArch. There's a huge repository where you can see what's there already. What we try to find is like creating working groups that can be localized, like, because you always have to work with someone who's around you, and just start to work on real projects ourselves and make it just more tangible and see, okay, that's already something, why don't I use that? And that's one of the biggest learnings that I had from my open source endeavor, is before you start to do anything new, look around and try to see whether someone else has done it before. And almost certainly you will find something that another person, another group has been working on, and just try to take off from where they ended and not doing reinventing the wheel again from scratch, which is...
But please feel invited to approach Max and
we can
Romana
have more detailed discussions.
Afterwards, and also feel everyone invited to approach our panelists, also us from the TUM Venture Lab Built Environment, to provide a bit of this safe environment and also to help you getting, or students, researchers, to get in contact with the real world. Thank you very much for being with us on stage today. Thank you very much for the audience.
Thank you.